let us see next method of preparation of alkyl halides. Okay, in last video we have seen method of preparation of alkyl halides by using alcohols. Okay, there we have three reagents were there we have seen, and by using those three reagents and alcohol how to prepare alkyl halides we have seen. Now here second method of preparation of alkyl halides is from hydrocarbons. Okay, see, alkyl halides are prepared from saturated as well as unsaturated hydrocarbons by various reaction. Now saturated means what? Carbon-carbon single bond. Okay, and unsaturated means carbon-carbon double bond. Okay, now see, from alkanes also we can prepare alkyl halide. Halogenation of alkane also gives alkyl halides, but this reaction is not suitable for preparation of alkyl halides because in this process we get mixture of mono and poly halogen compounds. Okay, so halogenation of alkanes give us mixture of alkyl halides. Okay, and that's why that method is not suitable for the preparation of alkyl halide. Okay, so here it is, one more method is there to prepare alkyl halides from hydrocarbons. So in this method addition of hydrogen halide to alkene is done. Okay, hydrogen halides means which? Hydrogen iodide, hydrogen bromide, hydrogen chloride. Okay, so these are hydrogen halides. These hydrogen halides are added to alkene. Alkene means what? Carbon-carbon double bond is there. Okay, the compounds which contain carbon-carbon double bond are alkenes. So these hydrogen halides are added across the double bond and alkyl halides are prepared. See, this reaction you have studied in standard 11 also. So let us see how the reaction takes place. So let us see first symmetrical alkenes. Okay, alkenes are of two types, symmetrical and unsymmetrical. Now symmetrical means what? If you see the double bond, on either side of double bond same groups are present. If you cut this molecule from here, you will get same parts or equal parts. So that is called as symmetrical alkene. Okay, the alkene which has similar groups on either side of double bond is called as symmetrical alkene. Okay, now first let us see the addition of hydrogen halide across the symmetrical alkene, across the double bond in symmetrical alkene. So let us see this example of symmetrical alkene I have taken, which is ethene, right? Two carbon atoms are there and one double bond is there, so it is ethene, and we are going to add hydrogen chloride in this. Okay, it is hydrogen chloride. Okay, now see what happens, how the reaction takes place. See, HCl means what? One atom of hydrogen and one in chlorine is there. Okay, so this one hydrogen and chlorine are going to be added across the double bond. Okay, now this alkene is symmetrical, that means both the carbon atoms are similar. Okay, so on one of the carbon atom this hydrogen atom will be added. Okay, and on one of the carbon atom this chlorine atom will be added. Okay, and then this double bond which is present in ethene will get reduced to single bond. Okay, now here already CH2 is there, this hydrogen will be added, so it will become CH3, right? Double bond will become single bond. Okay, and CH2, and on this carbon atom this chlorine will get added. Okay, so let us show chlorine over here. Understand? So what we have got? CH3, CH2, Cl. Okay, so two carbon atoms are there and one halogen is there, which is chlorine. So name of this compound is ethyl chloride, right? Understand? So in this way, when symmetrical alkene is there, that time reaction is easy. Hydrogen will get added on one of the carbon atom and chlorine will get added to another carbon atom, and product, that is alkyl halide, will form. Let us see one more example of this kind. Say this one more example. Here I have taken one more symmetrical alkene. Okay, CH3, CH, CH, CH3. Okay, how many carbon atoms are there? 4 are there. Okay, so parent alkene is butane, but here double bond is there, so it is butene. Understand? Let us write name of this compound. We have to do numbering first. Okay, and numbering should be done in such a way that double bond should get lowest possible number. Okay, now it is symmetrical compound, so from if you do numbering from either side, you double bond will get same number. Okay, means 1 2 3 4. Here also double bond is getting second position, and if we start numbering from this side 1 2 3 4, then also double bond will get second position. So let us start from here. Okay, so at second position double bond is there, and this is butene. Okay, so the name of this compound is but. Then show the position of double bond. Double bond is at second position, so but2-ene. Understand? Name of this compound is but2-ene. Now in this alkene we are going to add HBr, which is hydrogen halide, hydrogen bromide. Okay, so as the alkene is symmetrical, on one of the carbon atom your hydrogen will get added. Okay, and on one of the carbon atom bromine will get added. Okay, so see the product. This CH3 will remain as it is. Okay, then on this carbon atom we are going to add bromine, so CH and this bromine will come. Double bond will get converted to single bond. Then on this carbon atom this hydrogen will get added. It is already CH, so it will become CH2 after addition of one hydrogen atom, and then CH3. Understand? So this is alkyl halide, and name of this alkyl halide is 4 carbon atoms are there, and on second position bromine is there. Numbering will be done from this side so that bromine will get lowest possible number. So how the name of this compound will be written? 2-bromo and propane it is. So 2-bromo propane is IUPAC name of this compound. Okay, and if you have to write common name, then it is butyl, right? Butyl bromide. Okay, so in this way we can add hydrogen bromide across the alkene, which is symmetrical alkene. Understand? Now let us see how to add hydrogen halide across the double bond when alkene is unsymmetrical. Understand? Let us see that. See this example of unsymmetrical alkene. Okay, so see now how hydrogen halides are added across the double bond in unsymmetrical alkene. Now let us write the name of this unsymmetrical alkene. Okay, now 3 carbon atoms are there, so parent alkane is propane, and one double bond is there, so it is propene. Understand? This unsymmetrical alkene's name is propene. Now we have to add one hydrogen halide. Suppose hydrogen bromide we are going to add. Now here this alkene is unsymmetrical alkene. Okay, so on either side of double bond 2 different groups are attached. Okay, so now we have to think on which carbon atom, this carbon atoms, 2 carbon atoms we are going to consider. On one of the carbon atom hydrogen will get added, and one of the carbon atom bromine will get added. Okay, now we have to think on which carbon atom hydrogen will get added and on which carbon atom bromine will get added. Okay, now here Markovnikov's rule we have to follow. What is Markovnikov's rule? You have studied this in standard 11. This reaction also you have studied. Okay, now see, according to Markovnikov's rule, when we add unsymmetrical reagent to an unsymmetrical alkene, that time negative part of that reagent is added to the less hydrogenated carbon. Okay, now let us see first which part is positive and which part is negative. Now see, this is HBr. Okay, HBr. So in this compound, hydrogen is positive part and bromine is negative part. Okay, now negative part will get added to the less hydrogenated carbon. Now these 2 carbons we are going to discuss. Okay, so to this carbon atom 1 hydrogen is attached, and to this carbon atom 2 hydrogens are attached. So which is more hydrogenated and which is less hydrogenated? Obviously the carbon having 1 carbon atom is less hydrogenated. Okay, and the carbon which is having 2 hydrogen atoms is more hydrogenated. Okay, So according to Markovnikov's rule, negative part means bromine will get added to less hydrogenated carbon atom, means this carbon atom. So this bromine will get added to this carbon, understand, and hydrogen will get added to this carbon atom. Okay, and this rule is called as Markovnikov's rule. So let us see how the product will form. This CH3 will remain as it is, understand. Then on this carbon atom bromine is going to get added, right? So this CH and I added bromine on this carbon atom. Double bond will get reduced to single bond. Then CH, two hydrogens are already there, one hydrogen will get added, so it will become CH3, understand, and this product has formed. Now 3 carbon atoms are there, so it is propyl bromide, understand. So in this way, in unsymmetrical alkene, hydrogen halides are added, and here addition takes place according to Markovnikov's rule. Okay, now here in this case of unsymmetrical alkene, one more product is also possible, which takes place according to that is anti-Markovnikov's addition. So exactly opposite of this product will form. So see CH3, okay, and on this carbon atom according to Markovnikov's rule bromine has added, but if we take opposite reaction, anti-Markovnikov's reaction, here hydrogen will get added. So CH will become CH2, double bond will become single bond, CH2, and here bromine will get added. Okay, so this is also propyl bromide. Okay, but when products form, this product form in major quantity, more quantity, that's why it is called as major product, understand. This first one is major product and this one is minor product. Okay, now let us see what is meant by peroxide effect. Okay, so this reaction we have seen in which the product which is formed according to Markovnikov's rule is major product. Okay, this product is formed by using Markovnikov's rule, so this product is considered as major product and this is minor product. Now what is peroxide effect? If we want this product as major product, understand, if we want this product as major product or the product which is formed according to anti-Markovnikov's rule, opposite of Markovnikov's rule, anti-Markovnikov's rule, if we want it as a major product, then the reaction should be carried out in presence of peroxide. Okay, and that is called as peroxide effect. So same reaction when it takes place in presence of peroxide, it takes place according to anti-Markovnikov's rule. So let us see one example. See here, same example I have taken, CH3, CH, double bond CH2 plus HBr. This reaction will take place in presence of peroxide. Peroxide will be used as reagent. Okay, now see here exactly opposite reaction will take place. Okay, this part is positive part, this part is negative part. This carbon is less hydrogenated and this carbon is more hydrogenated, right? So in this because of this peroxide effect, this negative part of this reagent will get added to more hydrogenated carbon and positive part will get added to less hydrogenated carbon. See in first reaction how the things have taken place. Negative part has added to the less hydrogenated carbon and positive part is added to more hydrogenated carbon. Exactly opposite will take place over here. Okay, now see how the product will form. CH3, on this carbon atom hydrogen will get added, so it will become CH2, double bond will become single bond, and on this carbon atom bromine will get added, so it will become CH2Br. Okay, so in presence of peroxide effect, anti-Markovnikov's addition takes place, understand. So in this way we can prepare alkyl halides by using unsymmetrical alkenes. Okay, so now see some questions, some reactions are given in your textbook to complete. Use your brain, page number 213. Okay, now see the first, CH3 CH double bond CH2. Okay, in presence of HBr, you have to write both the products, major as well as minor. Same example we have solved. Okay, now on arrow peroxide or any reagent is not mentioned. That means here addition will take place according to Markovnikov's rule, and we have to show which product is major and which is minor. Okay, so here the product which will form according to Markovnikov's rule will be major. Okay, that will be major, and the another will be minor. So let us write both the products. This is negative part, this is positive part. This is less hydrogenated, this is more hydrogenated. Okay, negative part will be added to less hydrogenated carbon according to Markovnikov's rule. So here bromine here and hydrogen here. So CH3 CH Br CH3. Understand, this is major product, and exactly opposite addition means bromine here and hydrogen here. So CH3 CH will become CH2 and CH2Br. So this is minor product. Okay, now when peroxide is present, the reaction will take place according to anti-Markovnikov's rule. That product which is formed according to anti-Markovnikov's addition is the major product. Okay, now see, this is negative part, this is positive part. Anti-addition we have to do. That means bromine will get added to more hydrogenated carbon. Now see, across the double bond these two carbon atoms are there. On this carbon atom no hydrogen is present. So this is less hydrogenated and this is more hydrogenated. Okay, now peroxide effect is there. So negative part will get added to more hydrogenated and hydrogen will get added to less hydrogenated. So see the product, major product CH3 twice C. On this carbon atom hydrogen will get added, so it will become CH. Double bond will get converted into single bond, then this CH, and on this carbon atom bromine will get added and this CH3 will come as it is. Okay, so this is the major product. Okay, and minor product if we have to form, bromine will go on this carbon atom, hydrogen will go on this carbon atom. So if we have to write minor product, CH3 twice on this carbon atom bromine will come, double bond will become single bond. On this carbon atom already one hydrogen is there, one more will get added, so it will become CH2 and CH3. Understand? So this is minor product. Okay, and this last one we have solved. You can see that answer and you can write major and minor product. Okay, so here we have seen how alkyl halides form by using alkenes, symmetrical alkenes and unsymmetrical alkenes. So let us stop here.